Hi guys, so I bought two 150 amp hour lithium iron phosphate batteries from Alibaba, from a company called Belly, and these batteries have a low temp cutoff and also charging heating, and these are controlled of course by the BMS, and the scope in this video is to see how the low temperature cutoff works and if the battery starts heating or the internal heating elements start working until plus 5 degrees Celsius, when the heating should stop and the battery should start charging. I'm using this Victron Blue Smart charger, 15 amps, so not so powerful, but hopefully it will do its trick. According to the company, the heating elements, they need 5 amp current to be activated in the BMS, and 2 of these heaters require 7 amps. So that's about the specs. I've been freezing this battery for some time now. Unfortunately, I have a cabinet type freezer, so it's not too cold. As you can see from the app there, the temperature is at the moment minus 4.8 Celsius, and that is the temperature 1 sensor. So that is the temperature of the temperature sensor on top of the cells. Temperature 2 is minus 8 degrees Celsius, and that is the BMS temperature. So the voltage of the battery is 13.26, and the app itself shows 13.22. Let's hook up the cables. So first plug the charger. Okay, the charger is plugged, and the app crashes. You can hear the relays going. Okay, so the BMS has turned off charging. For some reason the application crashed. The current is decreasing. I'm not entirely sure why that is happening now, because the battery should not be charging, but I assume because the heating system works with the charger, so the charger is now feeding the heating pads. One should be here on the front side of the battery, and one should be here on the back side of the battery. The temperature is now minus 4.6. Current is still dropping. Temperature is minus 4.5. I think I can feel a little bit of warming on the front here, not on the back. So now we should just wait until the temperature is plus 5 degrees. Then the BMS should switch off the heating of the battery and turn on charging. So now the temperature is actually plus 1.3 degrees Celsius. So we should be maybe 10 more minutes and we should have plus 5 degrees Celsius here. And we can then see what happens. Oh yes, now the front of the battery is really warm. Actually the back of the battery is slightly warm as well, but not as the front, so I'm wondering if there is a pad here, or if it is it actually, yeah, it is warmer down here on the back side than on the top here, or on the side, so I guess there is a pad there as well, which is heating, but the front is really warm. Of course, I would like to see both sides being equally warm, so that you are sure that the batteries are sandwiched between the warm energy and heating well. Now I'm not sure if this side of the battery is sort of colder than this side, probably because the casing is anyway much warmer here on the front. Amperage is now down to about 10.1 amps. So I assume this is now the heating patch drawing energy from the charger, as that's how they are supposed to work, as far as I understand from the company representative when I ask about this system. Amperage is now 9.95. Voltage of the battery is still around 13.2. Voltage difference between the cells is 0.006 voltage, so pretty even. Battery is at, let's say, around 40% charge, state of charge. Actually I did the capacity test here, so it was around 160 amp hours, so pretty good. So now we have 4.9 degrees. Let's see what happens. All right, so you heard the click, so the relay in the BMS switch on the charging. So now the battery is charging. The application is showing 16 amps. The multimeter is showing 14.7. The charger is at bulk. So I don't know why the difference is 2 amps here. The battery itself is really warm in the front, and on the back not so warm. Let's see, maybe I can measure since the amperage is now pretty stable, so I'll just take this one. So basically there's a function for heating as well, and there's this kind of temperature probe, and you just plug it in like that. Now it shows about 23 degrees. Let's see if I can somehow, maybe like that. Okay, so that's the temperature now in the room, about 23 degrees. So the front of the battery, I'm now pushing this probe, or maybe you can see it better now. I'm placing this probe on the sticker, the front. The temperature of the front side of the battery is increasing. 30, almost 32 degrees. So that's about it for these batteries. I will also do the same test with the second battery, just to check that it is performing the same way. Thanks for watching. Bye.